Hello, today we're going to be talking about completing the square. So first we're going to look at general form, which is ax squared plus bx plus c. You probably all know that. And we're going to be looking at factorizing equations in a slightly different method to what you're probably used to. So let's have a little example here. X squared plus 4x plus 3. Yep, everyone knows this. It's just going to be x plus 3, x plus 1, because your 3 can be multiplied to become 3 and added to become 4. But completing this square is a slightly different method where you basically force this equation to have a perfect square in there. So let's just look at x squared plus 4x plus 3 again. So this, you can actually create a perfect square by using the adding and subtracting the same thing to become 0 method. Since adding one thing and subtracting the same thing is always going to be 0, you're going to utilize this to create a perfect square. So if we look at x squared plus 4x, and let's just move the 3 over here for a moment, we can make x plus 2 all squared by having a 4 here. So this would go into here. But obviously, if you've done this, if you've just added a 4, then the equation becomes x squared plus 4x plus 7, and you've changed the question. Now, we don't want to be doing that. We want to keep the question the same. So to negate this addition of 4, you can subtract a 4. So then we'd get x squared plus 4x plus 4 minus 4 plus 3, which is still actually equal to x squared plus 4x plus 3, according to this. So now, if we continue on, x plus 2 all squared, and then we've used up all of these guys, so now only these guys are left. So what's that? Minus 4 plus 3, or 3 minus 4, that would be minus 1, and then there you go. You got your completed of the square. Your completed square. So yeah, obviously this can be factorized still. X plus 2 minus 1, and then x plus 2 plus 1. Boom. And then this can become x plus 1, x plus 3. See, it's the same thing. So here we go, they're the same thing. Let's just try another example. X squared plus 9x plus 1. So step 1, ignore the c. So we're going to let the c be way over here. Then x squared plus 9x. Then 2. Obviously 9, it's relatively a large number. So you want to use the formula b on 2 all squared to get your c value, plus c value in your general form that you're going to be creating a square with. So x squared plus, it's going to be 9 on 2 squared. So 9x plus 9 on 2 squared minus 9 on 2 squared. And then plus 1, can't forget about them. All right, and then the third step is to factorize into the square. So then, can't forget them equal signs. Okay, so then we got our x plus 9 on 2. So the b on 2 value is what comes into here. I'll just summarize that later. So then plus that, and then we're left with our minus 9 on 2 squared plus 1. So then this is equal to x plus 9 on 2 squared minus 81 on 4 plus 1, which is equal to x plus 9 on 2 squared minus 77 on 4. And then you're done. You can also keep going if you want to. I feel this is unnecessary, but the curriculum disagrees. So x plus 9 on 2 plus root 77 on 4. And then x plus 9 on 2 minus root 77 on 4. So this is basically using the a squared minus b squared and then factorizing it into a plus b and a minus b. So since this here is this here is a minus value, you can technically call this a. All of this becomes a, and then this guy becomes b. So then you've created your a squared minus b squared. And then you can make it a plus b and a minus b. So b is 77 on 4, so it's root, and then this is root, but then the squared's there, so it cancels, and then you've got this, which is just ugly and all around annoying and completely useless. But you might get it, so here you go. Alright, so this is completing the square. Let's have a little summary here. So if we look back at our example, number 1, ignore the c. Here's our first step. Our second step is to add and subtract the same thing that would make the ax squared plus bx into a perfect square. Remember that you're going to use b on 2 squared if it's a large b value, because you can't just figure it out. Then third, we're going to be factorizing and making this a square, and then just doing the addition, and boom shaka wow, you're done. So that's completing the square.